We have already discussed how to solve application problems using the normal distribution. What we're going to look at now is using that for sample means. What we're going to look at now is trying to look at the possibilities in a distribution using means from all possible random samples. And so we're going to be looking at multiple samples, and so we're going to take the mean of the samples here. And the mean of the samples is going to be the same as the population mean. And the standard deviation of the sample means is actually going to be smaller than the population. It'll be equal to the standard deviation divided by the square root of the sample size. So what that looks like is we have the sigma of what we call x bar. So the standard deviation of the sample means is equal to the standard deviation divided by the square root of n. And this is what we're going to be using instead of just the standard deviation, because we're looking at multiple samples instead of just taking one person or two people. We're taking multiple random samples and getting a more accurate description of our data. We use the same type of z-score. We're just going to put this in place of our standard deviation. And so what that's going to look like is now our z is going to be our x bar, which means the mean of the samples, minus our population mean, divided by sigma divided by the square root of n. And you have to be careful when you do this calculation. You have to make sure that you do this division on the denominator, do the subtraction on the numerator, and then do the overall division. You can figure it like this. It works the same way. These are actually equal to each other. Again, it works the exact same way. You'll see it most of the time written this first way though. Okay, but make sure you're careful how you put it into the calculator. If you try to put it all in the calculator at once, make sure you're putting parentheses around the entire numerator and around the entire denominator. Otherwise it will change your answers. Okay? So let's look at an example of this and see what we mean. This says the average yearly Medicare hospital insurance benefit per person was $4,064 in a recent year. So the average yearly benefit was $4,064 with a standard deviation of $460. So that means that our mu is 4,064 and our standard deviation is 460. Find the probability that the mean benefit for a random sample of 20 patients, so that means that we're looking at a sample size of 20, is less than $3,800. So that means we're looking at the probability that our sample mean is less than $3,800. So we need to change this, just like we did before, into a z. So we want to draw our z-score over here, or our distribution. We have 4,064 in the center, and we're looking at 3,800 over here. So we're looking at 3,008 and This is not writing very well. Let me try this one more time. 3,800. And we're looking for less than, so I'm going to shade to the left. Okay. So I need to change this into a Z. And so when I do that, that is going to look like the probability that Z is less than, well, let me just change this into a Z first. Okay. So Z, my X bar is 3,800 minus my mean divided by my standard deviation divided by the square root of n. Okay? When I do the subtraction on the numerator, I get a negative $264. So a negative 264. On the denominator, if I take 460 divided by the square root of n, I get 120.859. And I'm going to want to try to keep at least 3-4 decimal places there. Then I'm going to take negative 264 divided by, I'm sorry, that should be a 102, not 120. Let me fix that. That should be a 102. There we go. 102.859. And I get that my Z is equal to a negative 2.5666, which, remember, we have to round our Z-scores to 2 decimal places. So Z is equal to negative 2.57. So we're looking for the probability that Z is less than a negative 2.57. Okay, remember that this is less than, so I just need to look it up in my table, which I have a copy of the table down here. Negative 2.57, so I come over here to the negative 2.5, which is right here, and I come across to the 7, so I'm looking for this column, and I come across this row, and I find that it is 0.0051. So I get that the probability that X bar is less than 3,800 is equal to 0.0051. Now remember, we always want to put this in terms of our problem. So the probability that the mean benefit of the 20 patients being less than $3,800 is 0.0051. Now notice, I put a lot of information in this statement. I said the mean benefit of the 20 patients. We want to make sure that it's not just the mean benefit of patients. We want to state how many patients are we looking at, and we're looking at the mean benefit, and we're looking at less than $3,800. Let's look at another example. We're going to look at the same Medicare hospital insurance benefit, but this time we want to look at more than $4,100. So this time I'm going to go ahead and draw my picture. In the center I'm going to put $4,064 because that is my mu. And so $4,100 is about right here. And I want more than, so that means I'm shading to the right. Okay. So I'm looking for the probability that the mean is more than $4,100. I need to change this to a z-value. So that means I'm going to take 4,100 minus 4,064, and since I'm looking at 20 patients, I have to take my standard deviation and divide it by the square root of 20. So 4,100 minus 4,064 is equal to a positive 36, and 460 divided by the square root of 20 is going to be the exact same that we got a minute ago, 102.859. I do the division, 36 divided by 102.859, and I get 0.34999, which when I round that z value, that's going to be 0.35. So this is the same thing as the probability that z is greater than 0.35. Remember, since we're wanting a greater than, we have to look up that z-score and take 1 minus, because remember, when we look it up, it's going to give me to the left. There's a lot of rules to remember, but remember, when you look at these tables, they show you that they're only giving you the area to the left. So if you want to the right, you have to subtract from 1. So we're looking for 0.35, so that's going to be on the positive table. So I'm going to come to 0.03 and then to the 5. So I get 0.638. So 0.638. I do the subtraction and I get 0.3632 for the probability that the mean is greater than $4,100. Again, I want to apply that back to my problem. So the probability that the mean benefit of the 20 patients being more than $4,100 is 0.3632. Remember, again, you always want to apply your answer back to the problem and make that into a statement. Again, in this problem, we had to do the 1 minus because it wanted a more than. It wanted to the right. Anytime you're looking these up, please make sure that if it's to the right, you're doing 1 minus. Practice some of these, and if you have questions, please feel free to ask.